Recall that we introduced sequence A sub n. I usually put bracket in to the left, to the right of an to represent a sequence. We introduce sequence as a function. For example, sequence an is defined as 1 over n. You can list the terms of this sequence by plugging values: 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. So a sub 1 is equal to 1, a sub 2 is a half, a sub 3 is a third, a sub 4 is 1 over 4. So these are the terms of the sequence that you have. Then we can visualize this sequence as we visualize a function and analyze the end behavior of the sequence. We can plot the dot. And visualize is sequence. So here we go. For example, for this sequence, a sub 1 is equal to 1, a sub 2 is a half, then you have a third, a fourth, a fifth. So as you can see, the behavior of this sequence is decreasing. We were interested in finding the limit of this sequence as n goes to infinity, or the limit of 1 over n as n goes to infinity, which is 1 over infinity or 0. And remember that we said the sequence converges to 0. We're using the topic and concept of sequence to define something new. Now we use sequences to define a new mathematical object. These are called series. So let us begin. A series is denoted by S, and here you have sigma, Greek letter sigma, to show the summation. So suppose you have a sequence an. If you list the terms of the sequence on the left-hand side, a sub 1, a sub 2, a sub 3, a sub 4, and so on, you can take these terms and add them together and define your series. The first term of the series is denoted by S sub 1, which is a sub 1. The second term of the series is denoted by S sub 2, which is a sub 1 plus a sub 2. The third term of the series is denoted by S sub 3, which is a1 plus a2 plus a3. The fourth term of the series is S sub 4, a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. And you continue this process from a sequence to a series. So S sub n is a1 plus a2 plus a3 plus a4 plus a5 plus an. You can continue this process if you stop at an, you're basically defining a series that has partial sum. So the partial sum of the series is denoted by S sub n, which is the summation of all of these terms, A sub I or A sub j, anything that you like, and I starts from 1 and stops at n. This is the partial sum. Infinite series, it doesn't stop anywhere. S is equal to the summation of A sub n and start from 1 and goes to infinity. So for now, let us remove this S to avoid any confusion. So in general, an infinite series is defined as the summation of ANs and start from 1 to infinity. What is AN? AN is coming from the definition of a sequence that you learned before. So this is the introduction to partial sum and infinite series. We say that a series is convergent if the limit of partial sum exists. So this is an important definition. We say that sigma an and start from 1 to infinity is a convergent series if the limit of Sn as n goes to infinity exists. So if you take the partial sum and the limit of the partial sum exists, you say that, hey, your infinite series is a convergent series. Otherwise, your series is called divergent series.